At its core, this series is about tools, how each new tool we build acts as a power multiplier, which inevitably speeds up the progress of everything. But knowing its end goal, it's hard not to want to jump to the power tools right away. Next up, I'm hoping we can start laying down the first steps towards that goal with power. After achieving the breakthrough of the material iron and formally entering the Iron Age, one of the next major developments in human history was the harnessing of nature to provide us with free power. And ultimately, that was the far-off goal that started the Reset series, the eventual goal of doing our own industrial revolution by building a steam engine.
Love to see a steam engine that you have built from scratch.
So we start the beginning steps of that today with the first part of building a water-powered sawmill. Everything we use comes from 8,000 generations of collective innovation and discovery. But could an average person figure it all out themselves and work their way from the Stone Age to today? That's the question we're exploring. Each week I try to take the next step forward in human history. My name is Andy, and this is How to Make Everything. First emerging around the 3rd century BC, watermills were one of the first ways to replace human labor with natural forces. Some of the earliest were used for the tedious task of grinding grains, was also quickly utilized for other tasks like powering bellows or trip hammers. The main watermill we'll be taking inspiration from is the Roman water-powered stone mill in Hierapolis in what is today Turkey. A pretty advanced design, it allows the cutting of stone with natural water power by utilizing gears and a crank. Instead of stone though, I want the primary focus to be milling wood and open up the possibility of building some bigger structures. So far, we've explored some of the main ways of forming squared pieces of wood, by either splitting and shaping them with wedges and draw knife, or by hewing with an axe. Both are pretty slow and labor intensive, but were only replaced when sawmills came into prominence. Let's use some modern technology to help plan this out with the help of today's sponsor, BricsCAD. As we get into more and more complex engineering challenges, rough estimates and basic sketches of designs start to become less effective. Thankfully, while we are limited to ancient technology to build our projects, our research and planning isn't so limited. BricsCAD is a CAD software package allowing you to easily lay out and digitally design pretty much anything from drafting, designing, architecture, or engineering in 2D and 3D. I was able to use BricsCAD to lay out a 3D model of a rough draft of our full water-powered sawmill and get a much more complete idea of how each of the components in it will eventually fit together. BricsCAD works with a familiar interface, offers flexible licensing, and you can try it out now for free with a 30-day trial. Check it out in the link below. So we have the rough plan for the mill now. So in this first video, we're going to focus on just the saw. The rest of the mill will require lots of milled wood itself, so it makes sense to start with a tool that can help us make the rest. The saw has existed since the Bronze Age, and even forms of it were made in the Stone Age as well. However, none of them were the most effective. The teeth weren't the sharpest, it never held an edge very well, and were incredibly slow and inefficient to use. Now in the Iron Age, with a tougher metal, we can refine the technology more and hopefully make a much more efficient saw. First up, we need some tools, specifically a triangular file for grinding and sharpening the teeth of the saw. So starting with a stock rod, I used a bent piece of iron to roughly forge a triangular shape into it. Then rounded and thinned down the handle. Next, shaped a billet into a die for carving the teeth into the file. I'm roughly following the process ClickSpring explored in one of their videos previously, where they also ran into the need of making primitive files, so I recommend checking out that video for more details on this process. After forging them roughly to shape, next ground and cleaned them up and coated them in a layer of charcoal and wrapped them in clay. Then, once the clay dried, baked it in a kiln. If done correctly, this should cause case hardening, where the carbon from the charcoal alloys with the iron to form a harder steel. This will allow the file to stand up against the other iron we'll be filing. Lastly, I began adding the teeth to the file. Testing out my crude file, it cuts and grinds pretty effectively, but with a lot of labor. So to maintain my own sanity, I'm going to swap it out for a more durable modern file for the majority of the grinding. First up, we're going to try and make the actual blade for the saw. Adri here to help me, kind of guide me. A kind of expert blacksmith previously helped us make a sword out of iron. I'm gonna get a little bit of help to kind of guide me on this. I'm gonna take this stock piece of metal, hammer it into shape, and then we're gonna use some files to put actual teeth into it. And then I'll eventually be putting this into a frame to make a frame saw that would have been used in the early Iron Age. Start hitting.
So it's thin enough that it wants to bend over, which is not a good thing. So we just have to make sure it stays straight and take really straight strikes. No, we're just going to draw it out a little bit and then go straight up, and then we put a hole in the end. That hole is where that pin goes, and that's what holds it against the frame.
All right, so we got it all forged out. We got a hole at the one end to hold the pin and keep it there, and then a loop there to put the wedge to hold it tight. Now what you need to do now is file in the teeth.
Forming teeth is a little bit of a gray area when it comes to saws of this period. We know that generally early iron and steel saws had their teeth cut via fly press. A method that survived in modern saw making is retoothing a saw with files. It's super simple, especially for a rip saw like this, to take these blanks and file the teeth in one by one as you go down rather than using a large fly press. Push down and cut the teeth out.
All right, so after a lot of filing and then more filing, I have all of the teeth in here, roughed in. So next I'm going to set them, which is kind of the alternating alignment. It allows you to cut a wider spot than the actual width of the blade. It allows the blade to pass through a little bit easier. It's kind of an issue I had with a lot of the other bronze attempts at saws. The teeth were a lot smaller than the actual body, so it always get jammed up. So this should hopefully allow it to clear a little bit better and get some nice wide cuts.
It's working.
Yeah. And then do it the other side, going the other way. is actually pretty effective. It's not even sharpened yet. Yeah, that is definitely a saw. It cuts surprisingly well, very promising, a lot better than our other saws. So next we need to put it into a frame. It's ended up being a bit more rigid than I expected. I can actually saw with it just as it is. It doesn't bend too much. But when we start going at some really large logs, putting a lot of force into it, the more tension we can have to keep it rigid, the better it'll be. So there's basically two types of frames you can do, and that's depending on if you're gonna do a cross cut or a rip cut. If you do cross cut, then it's more of a bow saw where you have a frame going up. Then if you're doing a rip, you have a square frame that goes all the way around it, and that allows you to cut this way. That's what we specifically had in mind for cutting up and milling our own logs. So we have a loop here to hold a wedge, and that'll keep it tight. We have a hole for a pin. So basically we just need to make a wooden frame, put some slots in it for the blade, put in the pin and the wedge, tighten it up, and we should be good to cut. Sharpen a little bit of a point on both of these sticks and cut some grooves into the receiving ends, and then cut some notches for the blade. Should be good to assemble this guy up, and hopefully it should all fit up. Yeah, some tension. So I have the saw all completed now with a crude frame that should allow us to rip some logs, and that'll be really useful. It's going to require a lot of lumber for the sawmill. It's going to be a lot of hand power going into making the first few batches, and hopefully we can get to the point where we don't need it. Hewing and splitting logs like we have done before was also continued for a while, but this method continued to improve and get better and better, eventually to the sawmill, which is our eventual goal. Got a wedge holding the tension. That should hopefully improve effectiveness of it. So this is the kind of the very first step of the watermill sawmill, which is going to be a lot of work and a lot of bigger pieces. This is probably about the smallest piece, but even then, this one took a lot of manual labor to produce. Just having to file each tooth in, realigning it, and sharpening it, and putting it in the frame. It was about 25 hours of labor altogether, probably about $200 worth of labor using the usual minimum wage $200 saw. And we'll see how much that adds up as we get into the full sawmill. This will kind of be a running total as we slowly build our water-powered sawmill. But for now, it's human-powered. We got a lot of wood to mill, so we can start using this to cut some more square lumber and can probably produce a better frame eventually using the tool itself, and hopefully unlock some a little bit more refined woodworking as we go. We can start taking this out into the field and producing some nice square lumber. Thank you everyone for watching. Thank you to all of our sponsors on Patreon. This is just the first step of a growing larger project as we get to the industrial age. If you want to see us tackle these large projects like that, support us on Patreon. Check it out in the link below, and thanks for watching.
If you enjoyed this video, be sure to subscribe and check out other content we have covering a wide variety of topics. Also, if you've enjoyed these series, consider supporting us on Patreon. We are largely a fan-funded channel and depend on the support of our viewers in order to keep our series going. Thanks for watching.